Uh, okay, so today, in today's session, I'll be covering ARP and RARP. That is nothing but address resolution protocol, and RARP is reverse address resolution protocol. So what exactly is ARP is nothing but see each and every machine. It could be a computer or printer in the network. It has got its MAC address layer 2 level, and it also does have IP address, which we call as the logical address at layer 3 level. So what exactly is a logical address? It has been explained in this slide.
Saraswati,
Yeah.
Saraswati, I have a doubt on DHCP. Uh, could you
The
tell me in one line?
Yeah, DHCP is something which is called as Dynamic Host Control Protocol, which is generally used when we've got a DHCP server in the network. Why we use it? To automatically assign the IP addresses across the network to each and every computer. What generally network administrator does is nothing but it comes up with the range, IP address range, and it configures it in the DHCP server. And the moment we connect the computer in the network, it we have this configuration, DSCP configuration in switch. So what it generally does is it forwards the request of IP address to the DHCP server, and comes back with the IP address, whichever is available IP address from the range, and it assigns that IP address to the host or the computer. That's how it works.
Okay, thank you.
Yeah. Now we've got okay. So this is so coming back to the main point, I was talking about logical address. So what exactly is logical address? And nothing but the IP address we've got, and it's 32 bits long, which I've already covered in the last session. What exactly is IP address? And we also do have physical address, which we call it as a MAC address. That is 48-bit long. So what exactly is MAC address? Any device you can check in the system settings, you will get the MAC address of that particular device. A uh, LAN card or the Ethernet card, it also does have the MAC address. That is 48-bit MAC address. All right. Uh, are you there?
Yes,
Hello.
Saraswati.
Yeah. So yeah.
Hello. Yeah.
Yeah. Are you there?
Yes, yes, I am here.
Okay. Um, yeah, so I was kind of getting a glitch. I mean, I don't know, but that's all right. Can understand. So now there is this, we've got two different types of mapping. The one is static mapping and the other one is dynamic mapping. So what exactly is static mapping is nothing but we generally create a table manually, and we assign the logical addresses against the physical addresses, means IP addresses against the MAC addresses in each machine, and we store it in each machine. So that's how I mean, we will be creating a table, and
Saraswati, could
yeah.
you please explain me MAC address? Because I started in IP address. I don't know MAC address using.
Yeah, we've got this physical address. Physical address is nothing but the address which we generally get from the machine or the machine manufacturer. The manufacturer comes up with a MAC address. It is 48-bit long,
Okay.
and I mean, I don't want to dive deep into the mapping stuff as such. I've got it from the internet. I was also going to the stuff. So whatsoever the static mapping, they have mentioned that what we generally do is we create a table which contains the logical address versus the physical address. That's how the mapping is done, and that is, I think, very old technology. We've got dynamic mapping in which we generally use ARP and RAR. So what exactly is ARP is nothing but address resolution protocol, and what is RARP is nothing but reverse address resolution protocol. So what it does, ARP, it finds out the physical address of the IP address specified in the packet or in the IP packet, the destination in the given packet. Like suppose if I am trying to ping IP address of the neighbor network or IP address of the computer from the given network, or might be the neighbor network. It depends what exactly it does. We've got IP address, source IP address, we've got destination IP address, source MAC address, and we don't know the destination MAC address. So what it does is nothing but it sends out the packet, the IP packet, it broadcasts all across the network. The switching is done over there, and the one to which it has been pointed, it checks out the destination IP and it forwards the packet to the destination IP, and then it comes back with the physical address of that destination IP, and it maps it in ARP table of the switch. That's how it works. So the the so-called process of forwarding the packet from the source to destination is ARP, and coming back like from the destination to source is called as RARP. Like it is reversing what it is saying that we sorry.
I'll listen to you.
Yeah. So the moment it gets the so-called the request of the MAC address for the IP address, it resolves, it comes up with the answer like, for this IP address, I'm here, I've been configured for this IP address, this is what MAC address is. So it is resolving from the MAC address to the IP address. So that is something reverse address resolution protocol. So over here, like ARP and RARP, we've got a logical address converted into physical, the physical into logical. That is RARP.
Okay, I understand.
And then we've got this ARP operation. In ARP operation, what like it had it in this particular slide, it has detailed the exact operation, like what exactly it does. Um, the the explanation which I mentioned earlier in the previous slide, it has been explained in those slides. Okay. And it's the same thing. You don't have to go through the, unless and until you want to prepare for the CCNA, which you have to. But then for that also you don't need to dive deep into the something like that. I've just came up with the basics. So what exactly, if in any interview or any I don't know, test, technical test, if they're gonna ask you regarding the ARP and RARP, you must be sure about the basics. You must be, aware of the basics. So this exactly what ARP and RARP does. What they have mentioned is nothing but the same process, what it does, and what you need to focus on is what is ARP, okay, and how does it work, and its packet. This structure you need to actually mug it. I cannot explain the entire stuff, but then you have to mug the stuff. I mean, it is not that hard to mug as it or to memorize as such.
Okay.
Okay, and then we've got this encapsulation of our packet is nothing but what it does is like how the so-called ARP request is stored in the packet, and they have explained this in this slide. Now we've got this destination address, source address, and we've got the data, and then we have got CRC, that is cyclic redundancy check. We've got preamble and SFD. Now this is something, SFD is something which we use to uh, define the start of the frame, like how the frame has started from the source, has gonna reach so it gets synchronized, the way it travels from the source to destination. So preamble is something which we use, like it is allowing devices on the network to easily synchronize their receivers clocks, providing bit level synchronization. So you don't have to worry that much about preamble and SFD as such. And because we will, if you want, we can cover it later, the each and every part. Okay, but the basic is like the preamble and SFD. It is nothing but a starting of the frame, and then it gets changed eventually when it reaches the destination.
Hello, Saraswati.
Yeah.
I don't understand this, and also don't understand packet. Why we use packet?
Huh. See, okay, which one? The packet you are talking? This packet?
Yes, yes, yes.
Yeah, the data is transferred in the form of packet. We've got data which is going to get encapsulated with the destination address source, which will be encapsulated. That's the first thing. And it will be having those tags, the type, then source address and destination address. The way it will travel through the network, it when it will reach to the switch will come, switch will check the destination address field, and it will check the source address field, and then it will check the CRC errors, cyclic redundancy check.
In this total process is a packet.
Yeah,
Okay, I
and
understand.
we've got this start frame delimiter and preamble. Why we are using it? Just to make sure that the frame has started from the source and will get changed eventually. There will be the changes in this field. What do we call that? This what do we call? What is that? Um, the way it will travel from the source to the destination, the preamble and SFD field is going to get changed accordingly. So that's how the packet starts from the source and reaches to the destination. Yeah. If you want, I'll cover this preamble SFD part and the data packet part in detail in might be later sessions if you want.
Yes, please. Yes,
Yeah.
please.
Yeah. Okay. And then we've got this. What exactly is this operations? Right. The sender knows the target IP address. Huh. Uh,
This is the operation of ARP.
operation of ARP, and then we got operation of, this is the operation of ARP. How? Okay, I've continued it into the next slide. Like what exactly is that? And
Okay.
have I covered it before? Okay, I'm really sorry I copied those lines. Might have mistakenly copied those, which is not necessary. Then we've got this RARP one. That is, again, I've already explained what exactly is RARP. And in the next slide, it is coming back with the IP address for the given specified MAC address. So the intelligent work is done by the switch. Okay. It is saving all the details in its ARP table. And we've got this packet format of RARP. What you need to do is you have to again memorize this thing, because in this packet it might be asked in any technical test or around that what exactly is hardware type and protocol and the stuff, like what exactly is sender hardware address. It's a one and the same thing, only in RAR in R the operation is request 3 and request, I mean it has been placed in request 3 and reply 4, but in RARP it is, in RARP it is placed in request 3 and reply 4, but in ARP it is
Request
placed
3
in
and reply for meaning.
that you have to, like, like when you say ARP packet, so it's going to be the first request and second reply. Like
Yeah.
we've got those uh, computer, so whenever it will ask for it, whenever it will for ask whenever it will forward the ARP packet, uh, what it will be doing, the request will be considered as a request number 1, and reply will be considered as a reply number 2. But however, for RARP, it will be different. Like whenever it will request for the RARP, okay, it will be considered as request 3, and reply, whenever it will get a reply, it will be considered as a reply 4.
Saraswati, I am getting amazed with this RP and RFP packet with a request. I don't understand the all. Could you please repeat me in step by step? I'm a little bit of confused on this.
You are getting reply from where? Okay, okay. See,
In step by step, if you taught me, it will easy for me to
yeah,
understand.
yeah, sure. See, as far as my understanding, when any computer in the network sends out the request, sends out the R packet or the request for the um, MAC address. What exactly happens is nothing but the request is considered as a request one, and when it gets a reply, it is considered as reply two. In the position, that packet format, the position is going to be request number one and reply number two. But however, being said that in RARP, it's going to be request number three and reply number is going to be four. You cannot, suppose over here in RARP, if you're going to request for the IP address against the MAC address, you cannot you cannot number it at one position. It will be request number three. Are you getting it?
Yes, I'm getting a little bit.
Yeah, it's not that hard as such. What you need to do
Okay.
is you need to memorize the packet format, and that too I'm not diving deep. See all those permeable and SFD. Whenever you come up with a show IP interface details, whenever you check the so-called interface details in the Cisco switch, what you need to check generally is CRC errors. Okay, why the protocol is down, all those information, all that information, not those, sorry, all that information needs to be thoroughly checked. Then only we can come up with the conclusion. There was this problem with the line, or might be with the physical MAC address or the hardware. The problem was with the hardware. It all depends upon those factors. But you don't have to actually take care of those things, because see, if you want to focus totally on Cisco technology, then you have to take care of those. But if you want to pursue your career in OCI, then this all is like nothing. All right, you just have
Okay.
to know. Yeah, you just have to go through the basics, like what exactly is ARP, what exactly is RAR, and the stuff.
Okay.
So this is something which is called as TCP/IP This is yeah, this slide is coming up with an explanation of TCP/IP fundamentals, which I've already explained in the last session. So I again came up with that. What exactly is TCP/IP is nothing but like all those layers, right, which I've explained, or might be Soumendra has explained.
Yes, yeah, I
Yeah,
understand.
yeah. At network layer, we've got this IP, a protocol working, layer 3, and at network interface layer, data link, physical layer and data link layer, we've got MAC address working. Like it's going to be Ethernet, token ring, or other protocols. But however, being said that at transport layer, we've got TCP and UDP. So what is TCP is nothing but connection oriented protocol, and what is UDP is nothing but connection-less protocol. So what it does, like connect, what you mean by connection oriented is nothing but it will make sure that packet has been reached and it will ask for the acknowledgement.
Okay.
And what is UDP is like it will never ask you for the acknowledgement. It will keep sending the packets in any manner. It will never check the acknowledgement, or it will never follow the process. Okay, now coming to the next slide, I've already explained this. What exactly is TCP and what exactly is UDP? UDP is nothing but user datagram protocol, and TCP is transport control protocol. So where
Please
we generally,
explain me in this process, TCP sender receiver, which process is there follow? Please explain me.
yeah, sure. Just give me a second.
Yeah.
Just give me a second.
Yeah.
Yeah, I don't mind. Like, okay, what exactly is TCP is like? Whatever you will be the synchronization, whenever you are sending the packet, what it will this receiver will do is like it will come up with the acknowledgement. So it will be sending the packet. This receiver will reply back, and then it will mention that I've got the packet and this is acknowledgement. That's how the entire three-way handshake process will be completed. So TCP is something which is called as, okay, I know you. Now the front end person or the host will say, yeah, I also know you. I know your IP address and the stuff. And then the again the one source one will come up with the acknowledgement. Fine, I got it. Something like that. And UDP is something is like it will keep sending the packets. without even acknowledge, without even waiting for the acknowledgements or any other stuff. So where generally we use UDP is TCP we use in everywhere. We use it in each and every technology that we generally use. We use it in load balancer. I mean, the entire IP thing, it is based on TCP. And UDP is used in applications wherein we are not that keen about the acknowledgements.
Okay.
So might be, I'm not sure, but then like for the DNS queries or might be streaming audio or video, like whenever you are using IP trunk, voice over IP, in that case, it's not going to consider the so-called acknowledgement. But however, it will consider the acknowledgement when you are using the routing protocol or when you are using DS. I think whenever you are using any routing protocol or ARP, RARP, all in all those scenarios, the TCP will be used, but UDP will be used in voice technology. Voice technology in the sense IP, trunk, VoIP, or might be DNS queries, domain name system. Okay, so that's how it works. In VC, video conferencing, it will not check, like suppose we are having this connection, this screen sharing connection, right? Or any video meeting. What it generally does is it keeps forwarding the packet. It will never ask for the acknowledgement. That's how it works.
Okay.
Now over here in this TCP versus IP, what exactly is the difference? I already mentioned, like TCP is transfer control protocol. Both of them, they work together. And TCP is at layer 4 and IP is at layer 3. TCP is responsible for transporting and routing data throughout the network architecture. IP does the same, but TCP comes up with the sessions. So see, at physical layer, we've got the data, which is gonna get uh, counted as in the form of bits and bytes. But at the data link layer,
Yeah, yeah.
we call it as frames, and network layer we call it as packets. At transport layer we call it as segments, and at session layer we call it as sessions, and then it goes up. So at transport layer we are calling it as in the form of segments. Again, I've explained it in not that much in detail as such.
Saraswati,
Yeah.
hello.
Yeah.
Please, please wait for a minute. I want to read it. What is the difference?
Okay.
If I have any doubt, you will recently
Yeah, sure.
explain. Hello, Saraswati. Thank
Yeah.
you for explaining. I understand it. Thank you.
Yeah. Yeah.
Please forward it. Yeah.
So I mean, what exactly is TCP and IP? IP is
Yeah,
something
yeah.
at layer 3 and TCP it works at layer 4. TCP, whenever TCP is something which you call as a platform wherein all other protocols work, like HTTP or email SMTP or SSH or FTP. All those protocols are considered in transport layer or transport layer. But however, I was also confused a bit because we are also considering HTTP and SSH and all other protocols at application layer. I mean, whenever we try to connect to the computer using SSH, right? We do that right from the scratch, from the application layer. So if that is a thing, then what exactly TCP is doing? But then again, we have got so many routing protocols in Cisco technology, which we are not so many as such, but we have got those couple of routing protocols. They've got the TCP port number as well. So the entire scenario, like considering, and that again, that routing thing, like we've got EIGRP, RIP, and everything, all those things are considered at layer 3. Okay, we are not considering it at layer 4. Then again, what we mention is it has got TCP port number, and like BGP has TCP port number 179. So why the hell we are coming up with the TCP? Why we are merging or mixing the TCP into IP at layer 3? I am not understanding that. If at all you get a chance, you can ask someone like why we are doing that, right?
Okay.
Yeah. Okay. Again, I have came with this explanation regarding the detail, not detail aspect, the brief explanation about switches and routers. What exactly switch does is nothing but transferring the frames from switches. We do have layer 3 switches, we do have layer 2 switches. It does work on it does take care of IP addresses with MAC addresses. Switches does have ARP table, RARP table. What it breaks the collision domain, and what exactly is collision domain and what exactly broadcast domain, that I'll be covering in the next session. Switches is something like you can use a switch, layer 2 switch, within one network, which has got only one IP range. Like earlier in the IP subnetting session, I cleared the subnetting part, right? What we are doing is we are segmenting the network into two different subnets.
Yeah,
So
okay.
to connect, yeah, when you want to connect those two different networks or two different subnets, you use either router
Saraswati,
or
I want to ask a question. Last class, I have a doubt. Why you use subnet max? Why you had need of this subnet max?
that ISO has came up with this particular technology so that we can segment the network. Why we are using it? So that we can define the classes. So we have already defined the classes. For class A, it's going to be 255.0.0. That's how we can identify or segregate the classification of IP addresses.
Okay.
And routers we use to connect two different networks. Layer 3 switches also used to connect two different networks. Layer 2 switch is used to connect two different hosts or computer within the same network. And then we've got the firewall, which is used to connect the internal network to the internet. Or you can actually take care of security using the firewall. So I've drifted over here, and we've got this voice gateway as well. What exactly is voice gateway is nothing but when you want to use, when you want to
Saraswati, I don't understand what use of a farewell.
the firewall, it is used to connect the internet. See now, basically whenever you got the modem or layer 3 switch, you can always connect the stuff, connect the internet, or you can take whenever you want to go out of your internal network, you generally use matting. Okay. In that scenario, whenever you want to connect to the internet, but however being said that, um, in like suppose if you got the modem, if you got the what do you call the so-called access point, and even you have got the connection from the service provider, in that scenario also you don't need the firewall as such, but then we use it for the security purpose of the internal network. That's the basic thing, to securize the network so that the private network will be securized. um, and also we use it for the NATing purpose. Like you got the public address, public IP address range, and you got the private IP address range, then the firewall does the does the mapping. There are two different mapping. I'll cover it in the later session.
Okay.
And we've got this voice gateway. what exactly is voice gateway is nothing but to connect the enterprise VoIP network with the telecommunication provider. So we've got suppose PSTN link or SIP line or ISDN link, SIP link or PSTN link from the service provider. Could be Airtel, Vodafone, Reliance. Then what it generally does is it will either travel through the IP network, through the established IP network that we call it as a VoIP, or we can use the ISDN lines for the so-called PBX like landline numbers and the stuff. So
Uh,
for that reason also we use voice gateway, and that's it. That's all for today. And okay, so tomorrow I'll be covering uh, session regarding, if you want I can cover it on Friday, or if you want I can cover it tomorrow as well, regarding what do we call that,
Please arrange a
base.
meeting tomorrow. If I have any doubt, you will clear me and
Yeah,
give me some idea on other provide to that.
yeah, sure, I'll be covering the slide which I've shared today. I'll be covering
Yeah, yeah.
the entire session. Okay, thanks a lot. Have a good
Thank you.
Take
Thank you,
care.
Saraswati. Thank you so much.
Yeah.